Hello, welcome to this channel. My name is Enoch. Today we will be starting a new series on containerization, and we'll be doing an introduction of containerization. We'll look at containerization as against virtualization. We will look at container runtime environment, and we will look at container image. Then we will do an exercise on how container works. We will get an HTML template. We will use it to build, a container image, and we will run the image. We'll run the container and we will validate it on a web page. So let's get right to it. What is containerization? Containerization is a lightweight, portable method, to package and run applications along with their dependencies in an isolated environment called a container. So we can say a container is a lightweight, portable and isolated environment that packages an application and all its dependencies, ensuring that it runs consistently across different computing environments. So container uses OS level virtualization. In my earlier videos, I discuss about the virtualization, where we look at different types of virtualization, and we discuss desktop virtualization, and some other types of virtualization. But this one is OS level virtualization, where the process, the file system and the network is isolated, but the container will be sharing, the the host operating systems kernel, while keeping application isolated, from each other. So this makes container faster, more efficient, and easier to manage than traditional virtual machine. So the key point that we need to note about containers is that containers are isolated. Each container runs its own application and dependencies, isolated from other containers. And a container provides process, file system, and network isolation. A container is also lightweight. Container does not need to run a full operating system, like the virtual machines. They share the host operating systems kernel, reducing the overhead compared, to the VM. So which makes them more efficient in terms of resource usage. Containers are more portable. You can package an application and its dependencies in a container and then run that container on any system that support the container engine. So once you have the container runtime environment, you can easily run the container on that host. A container also starts, fast compared to a VM because of the full operating system that has to come up in a VM. Virtual machines take longer time to boot, minutes to boot than container that boot, within seconds. So container boot up in seconds, unlike VMs that require an entire operating system to boot up. Container 2 is scalable. It supports dynamic scaling in the cloud environment. So you can see in this image, you have your server, which is like your virtual machines or whatever host you are using. Then you have the operating system on that server. Then you have your container runtime environment. An example of that container runtime environment is the Docker engine. And on that, multiple containers can run in an isolated environment. Each one will have its application and its binaries or libraries, configuration files, processes running isolatedly. So that's that. Talking of containers, as against virtual machines, virtual machine is, like a computer, sharing its resources with multiple computers. So you can see the virtual machine has its own operating system, its binaries and libraries, an application, so it takes more time to boot, to come up, as against a container that only has the binaries and libraries or whatever things are needed for the application to run. So containers are lightweight, they are portable. You can consider them as like OS level virtualization. In as much you have the container runtime environment, which is the container engine, the container will run on any host. So containers boot faster than virtual machines. They are effective They don't consume a lot of resources. They are lightweight. You can ship them anywhere to run them in any environment. So that's that about containers versus virtual machines. And we're talking of the container runtime environment. Is a software responsible for executing containers on a host system. So it allows applications to run, in isolated environment while sharing the same operating system kernel. The runtime manages the container lifecycle, including starting, stopping, and destroying the containers. And the primary responsibility of the container runtime environment is includes container execution, which runs container from container images. To run a container, you need to first create the image, and you use the image to create the container. So a running container is an instance of an image. So another responsibility of the container runtime environment is process isolation. It ensures that each container is isolated from others while sharing the OS kernel. Resource management, it allocates CPU, memory, storage, to running containers, and it also manages networking. It establishes communications between containers and external systems. One of its responsibilities is also security enforcement, which uses namespaces and control groups, to provide isolation and restrict resource usage. It also does storage management by handling persistent and ephemeral storage, for the container. Examples of container runtime environment include a Docker engine. Docker engine is the most widely used container runtime environment, and is responsible for managing and running Docker containers. Another container runtime environment is Containerd, which is a core component of Docker and is also used by Kubernetes, to manage container execution. We also have the container runtime interface Open, which is a lightweight container runtime, for Kubernetes, designed to work with OCI compliant runtime like runc. We also have the cron, we have the podman, we have the runc, and so on and so forth. So, but the most popular container runtime environment is Docker, and Docker is the one we are going to be using in this video today. So, talking of container images, container image is a static, portable, read-only template that contains everything that is needed to run an application. Think of it as a snapshot of an application at a specific point in time, including its code, its runtime, libraries, environment variables, and configuration files. So once a container image is built, it doesn't change. It's immutable, and the immutability ensures consistency. So any container that is instantiated from the same image will behave identical. Container images are platform agnostic. So as long as the host system has a container runtime, like Docker or Containerd, the image can be run anywhere, making deployment across different environments smooth and reliable. And since container images are immutable, they serve as version control artifacts. You can tag images with versions and send them to an image repository, like a public repository like Docker Hub, making it easy to roll back to a previous version if something goes wrong. So when you run an image, you get a container, an isolated running instance of that image. So let's go to our exercise, which will be on how container works. We'll be using an Ubuntu server. We will do a Docker installation. We will create a Docker image, and we will create a container from the image and confirm the web page from our container. So we will be getting a template from twoplate.com. All right, this is AWS console. I'll be creating an EC2 instance. All right, now let's log into our instance using SSH. So I will SSH into my instance. clear our screen, and let's go and install Docker on this machine. That's the first thing. So let's go through Google and let's say install Docker on Ubuntu, and let's take this, and on our machine let's just do an apt update. This is an Ubuntu machine, apt update. Let that one keep going, and let us go and see. This is a Docker engine installation. Let's just scroll down. Okay, now this is the instruction to set up. So I will just copy everything once, but you may not do that. You may do the command one after the other, but I will just copy it once just to save time, and I will just my shift insert is not working. I don't know why. I will check that later. All right, that one is done. Let's try and let's install Docker now. We have the repository, we have the key already. Let's install Docker. Alright, while Docker is installing, well, the first instruction there is just to confirm that Docker has been well installed. You can just run docker run hello-world, and this will pull the hello world image from Docker Hub, and it will download the image and run the container. So let's do that, and let's see. Docker run hello-world, and let's do that, and you can see that we have unable to find image hello world locally, so it's pulling it from the library hello world, and pull complete hello from Docker. This message shows that your installation appears to be working correctly. So let's clear our screen. We have Docker. If you type Docker images, you will see that Docker the hello world image is there. But if you check Docker PS, which is going to check the running container, you will see that the container exited, so it's not running, but it ran and exited. So that's that. But if you check your Docker PS-A to check all the available containers, then you see hello world container ID. You can see exited 50 seconds ago, and the name of the container. So that's that. I can let's do a Docker run name, name. Let's name this app01, and let it run at the background, and let us put a port mapping 9080:80, and let's call it Nginx. So this is going to get the image of Nginx from Docker Hub. It will download the Docker image, and it will run the container. So let's do that. So you can see it's downloading the image. Now the image has been downloaded. Let's check it. Docker images, then you see Nginx images there. If you check Docker PS, you see that Nginx is running, and you can see the name we gave it, app01, and you can see the container ID. So let me clear my screen just and let's do a Docker inspect. And let's give it you can give it app01, and these are the configuration of the container, and you can see the IP address of the container. If you do call http colon / 172.17.0.2. You will see colon 80. That's the port number of the container that we give the container. So you can see that's the Nginx HTML page, and if using Docker PS again, you see the port mapping 9080 that we gave it, and we can use we can use the IP address from our machine to check, to check it that is working. So colon 9080. This will not work. We need to go and work on the security group so that it will allow port 9080. So let's go to our security group. Click the security group of the machine, and let's edit the inbound rule, and let's add a rule and a custom TCP, and let's do 9080 from my IP, and let's save this rule, and let's go back and let's refresh. You can see welcome to Nginx. So that's that. This is coming from the container, from the Nginx container that is running on our machine, and that's that. So let's clear our screen, and let's try and create our own. Let's try and build our own image, and let's try and do that. Let's create a directory. I will name it images, and I will get inside it, and let's create a Docker hub. Don't worry, I will still explain this in my subsequent video, how to create your own image. We'll do the anatomy of container images, from beginning to the end. In subsequent video, I'm just laying the groundwork, for us to have an understanding and to see how container works. So VIM Docker file, capital D, and let's do this. And let's look at this. So from Ubuntu latest as build image, run apt update, run apt install wget unzip -y, wget to get. I've gotten a template from twoplate.com, an HTML template. We'll unzip it, then we will get inside it, and we will archive it, and we'll move it into /root/wedding.tgc. I just give it that name, and then let's move down apt update again, apt install Apache 2, just to give you a little bit understanding of of this instruction. Git, install git wget, then from the build image above, then you have /root/wedding.tgc. This is the archive file, and we are using the HTML location, in Apache 2. We are using Apache, and the volume Apache 2, the working directory, and we expose port 80, and that's it. Now let's build our image. Docker build -t. I gave it a name, test img, test image. Then we give the working directory where the Docker file is, the path to where the Docker file is, and let's press enter for this. And this will build the image. You can see it's building the image now. Our image build is completed. Let's check it out. Docker images. Then we can see the name I gave it, test img. That's the image that has been built. And now let's go and run our image now. Let's say Docker run -P to choose a port mapping, to choose a port number for us randomly. Then run in the background. Then we'll give the image name, which is test img, and we're on that. Now let's see something has happened. Let's check it. Docker ps, and you can see our container is now running. You can see that's the container, that's the image name, that's the container ID 7 seconds ago. Let's see the port number that it gave us, 32768, mapped to this is the host port. This is the host port, and this is the container port, and this is the name of the container. So 32768 is the host port, and the container port is port 80. So that's that. Let's check that our container is working as expected. Let's get do our security group to ensure that we can access our page. Let's edit the inbound rule, and let's add a rule, and the port number is 32768, and let's get it from my IP, and let's save the rules, and let's go and use it. So we have let's get the IP address of this instance. So let's get the IP of this instance, and let's go and use it. So the IP address, so that's the IP address of the instance, and the port number is 32768, and press enter on this, and we will get that's our template. So this particular web page is coming directly from the container, and so that's just, you know, a little bit of example of how container works. It's portable, you can ship it anywhere. Anyone that has this image can run it, and it will get the same web page, the same behavior as is working here. So let's do some cleanup. Let's do docker stop, and let's use our name of wonderful underscore Mosar, and let's stop other images to app01. Stop them, and we will also remove all the containers. Okay, the containers have stopped running. If you type ps, you will see that no container is running now. Let us remove the containers. I can just use the previous command, and let's rm, and let's remove all the containers. So if you run your docker ps-a, you will see that okay, we still have the hello world image there, container there. So I will just remove it. Docker rm vigilant underscore dirac, and that one is gone too. So if you run your docker ps-a, you will see that we don't have any available container again. Then I can say docker images, then okay, so let's remove all the container images just to do a cleanup. So those images are gone. If you run your docker images, you will see that we don't have any more image. So that's our cleanup, and we will shut down our machine. So thank you for watching. I will see you in my next video. Thank you.